Welcome to the deep dive. We cut through the noise to get you, our experienced investor and developer audience, the real details.
Yeah, we aim to give you that deeper perspective.
So today we're plunging into maybe the critical challenge in crypto scaling. How do you handle massive transaction demand without, breaking decentralization or security? That classic blockchain trilemma.
It's the million-dollar question, isn't it? If blockchains want to be the foundation for,
Yeah.
well, everything, they have to scale. And that tension is exactly what we're breaking down today.
Right. And our mission here is to give you those nuanced details. We've looked at a ton of stuff, official docs from the Enterprise Ethereum Alliance, deep dives on dank sharding from ethereum.org, plus analysis from places like Cointelegraph, Forbes, CoinLedger.
And we're also looking at the competition, right? Cardano, Solana, Cosmos,
Yeah,
how they're tackling the same problem.
exactly. We want to unpack the scaling issues, the limits, the opportunities, everything shaping Ripto's future. So let's dive in.
Okay, so the fundamental problem, especially for blockchains like Ethereum, was originally built, these monolithic chains, it's their architecture. Every node, every single participant on the network has to do everything all at once,
Everything meaning.
meaning consensus agreeing on the state execution, actually running the transactions in smart contracts, and data availability, making sure all the data is there, all done by every node.
Wow. Okay. So that sounds inherently slow. If everyone has to do all the work, what's the real world impact of that for, developers building or investors using these networks?
Well, it hits you directly in a couple of key ways. First, transaction speed. Historically, Ethereum's only managed about, 15 to 30 transactions per second? TPS, Bitcoin's even lower, maybe 7 TPS.
Which is just nowhere near enough if you're aiming to be a world computer, right?
Not even close. And this limit comes directly from prioritizing decentralization and security, making sure the network is robust and trustworthy, but that came at the cost of speed. It's that trilemma in action.
And the symptom everyone feels most acutely: gas fees.
Oh, absolutely. When the network gets busy, congestion drives those fees way up. You might normally pay, say, $2 to $40, but we've seen crazy peaks like $200 during hype cycles.
Yeah, I remember some of those times. Makes doing simple things like a quick swap or minting something just totally uneconomical for a lot of people.
Exactly. And beyond the fees, there's this growing problem of data overload. If you want to run a full Ethereum node today, you need to download the entire blockchain history. That's around 11 terabytes now, and it just keeps growing.
11 terabytes. Wow. That's a barrier. It makes it harder for regular people to run a node, which sort of chips away at decentralization, right? And it must slow things down too.
It definitely complicates running a node and indirectly impacts throughput. Yeah. So those are the challenges, big ones.
Okay, so faced with all that, how is Ethereum, the big player here, planning to fix it? You mentioned they're moving towards something different.
Right. A really ambitious transformation, actually. They're shifting from that monolithic design to what's called a modular architecture. The idea is to separate those core functions, consensus, execution, data availability, into distinct layers or components.
So each part can be optimized separately?
Exactly. Instead of one thing doing everything okay-ish, you have specialized components doing their specific jobs really well.
And the first big step towards that was the merge.
Yes, the merge in 2022, moving from proof of work to proof of stake. Now, the merge itself didn't directly boost scalability, like TPS didn't suddenly jump, but it was absolutely foundational.
How so?
Well, first, it massively cut energy use, over 99%, which was huge.
Yeah.
But technically, it laid the groundwork, the necessary foundation, for the scaling solutions that came next, the ones we're seeing roll out now.
Okay, so the merge set the stage. What came next? Layer 2s.
Precisely. Layer 2 scaling solutions focusing on taking execution off the main Ethereum chain, off Layer 1. And the main players here are rollups.
Rollups. We hear that term constantly. Can you break down what they actually are?
Sure. Think of them as separate blockchains built on top of Ethereum. Their job is to handle the bulk of the transaction processing, the execution, off-chain. But, and this is key, they still rely on Ethereum's main layer, Layer 1, for security and finality. They inherit Ethereum security.
How do they do that? How do they process off-chain but stay secure?
It's pretty clever. They take a whole bunch of transactions, could be hundreds, even thousands, and they batch them together off-chain. Then they submit data from this batch back to Ethereum Layer 1, usually in a compressed format, as essentially one single transaction.
Ah, okay. So lots of user transactions become just one transaction on the main chain.
Exactly. And that dramatically increases the effective TPS. Some rollups are already hitting, say, 1,000 TPS in production. We've seen testnets pushing towards 10,000 TPS.
And the cost impact. if you're only paying gas for one L1 transaction instead of hundreds.
The savings are massive. That layer 1 gas fee gets split among all the users in the batch. So individual transaction costs can drop down to like 0.03 cents to 25 cents. That's easily a 10x, sometimes even up to 80x improvement compared to doing it directly on L1.
That's a huge difference. Now, I know there are different types of rollups, right? Optimistic and ZK.
Correct, two main flavors, and they have different ways of ensuring those off-chain transactions are actually valid. First, you have optimistic rollups,
Optimistic because...
because they operate on an innocent until proven guilty basis. They assume the transactions submitted in a batch are valid by default.
Okay, but what if they're not?
That's where the challenge period comes in. There's typically a window, often about a week, after a batch is submitted to L1. During this time, anyone watching the chain verifiers can analyze the batch. If they spot an invalid transaction, they can submit what's called a fraud proof.
A fraud proof. And if they prove fraud?
If the fraud proof is successful, the transaction batch is reverted, and the entity that submitted the batch, the sequencer, gets penalized. They usually have funds bonded, staked, and that bond gets slashed. So there's a strong economic incentive, to be honest.
Makes sense. So examples of these would be?
The big ones you probably know are Arbitrum, Optimism, also newer ones like Base and Blast. Optimism's also doing interesting things with their OP stack, which lets developers easily launch their own custom Layer 2 chains based on Optimism's tech.
Right. But that 1-week challenge period, that sounds like a drawback.
It is the main trade-off, yes. It means if you want to withdraw your funds from the optimistic rollup back to Ethereum Layer 1, you have to wait for that challenge period to pass. So withdrawals can take about a week.
Okay, so that's optimistic. What about the other kind, ZK rollups?
Zero-knowledge rollups, or ZK rollups. These take the opposite approach. Guilty until proven innocent.
How does that work?
Instead of assuming validity, every single batch of transactions submitted by a ZK rollup comes bundled with a cryptographic proof, usually a ZK snark or ZK stark. This is a complex mathematical proof that guarantees the validity of every transaction in the batch.
Guarantees. Without revealing the actual transaction data, that sounds powerful.
It is. The zero-knowledge part means the proof confirms the transactions are correct without revealing any underlying sensitive information. It's a major cryptographic breakthrough.
And the big advantage here compared to optimistic?
Immediate finality. Because the validity is mathematically proven up front, once the ZK rollup batch and its proof are accepted on Layer 1, the transactions are final. There's no week-long challenge period needed. Withdrawals back to L1 can happen much faster, almost instantly in crypto terms.
Okay, so ZK sounds like the end game, maybe. Faster finality is a big deal. Examples?
Definitely seen as a more advanced solution, yeah.
Yeah.
Examples include Starknet, ZK Sync, Scroll, Linea. And there's also Mutable X, which is really focused on the NFT and gaming niche, offering gas-free minting and trading by leveraging ZK tech.
But are there downsides to ZK? If it's so good, why use optimistic at all?
Complexity, mainly. Generating those ZK proofs is computationally intensive, much more complex than the optimistic approach. Building ZK rollups, especially ones that are fully compatible with the Ethereum virtual machine, the so-called ZK EVMs, is technically very challenging.
So it's harder to build and maybe more expensive to run initially.
Historically, yes. Optimistic rollups got to market faster and captured significant usage because they were simpler to implement, but ZK tech is advancing incredibly rapidly. The development of efficient ZK EVMs is a huge focus in this space.
Interesting dynamic. So for our listeners, the investors and devs, optimistic rollups might be leading in usage now, but ZK potentially offers that superior finality down the road, especially when ZK EVMs mature. That could definitely shift things.
Absolutely. It's a space to watch very closely. And we should also briefly mention there are even hybrid solutions popping up, like Validiums and Optimiums. They play with where the transaction data is stored sometimes off-chain entirely to reduce fees even further, but that comes with different trust assumptions about data availability.
Okay, so that's layer 2's handling execution off-chain. But you mentioned Ethereum is also evolving its own layer 1 with sharding.
Yes, but the sharding plan has actually evolved quite a bit. The original idea was to split Ethereum itself into, like, 64 smaller shard chains, each processing its own transactions and smart contracts execution sharding.
But that's not the plan anymore.
Really. The focus shifted. With roll-ups handling execution so effectively off-chain, Ethereum realized Layer 1's main bottleneck was becoming data availability. just having enough space to store all that compressed data coming from the rollups cheaply and efficiently.
Ah, so layer 1 needs to become a better data layer for the layer 2s.
Precisely. So the plan pivoted to data sharding, which is now often called dank sharding, named after the researcher Dankred Feist.
Dank sharding. Okay. And the first step of that already happened.
Yes, the first major step, called Proto-Dank Sharding, or EIP 4844, went live in March 2024 with a Denkin upgrade. This introduced a new concept called data blobs.
Blobs, like binary large objects.
Kind of. Think of them as dedicated chunks of data attached to Ethereum blocks, specifically designed for roll-up data. The key things are, posting data in blobs is much cheaper than using the traditional call data method, and importantly, these blobs don't need to be stored by Ethereum nodes forever. They're automatically pruned, deleted after a set period, roughly 18 days.
Why delete them?
Because Layer 1 doesn't need the full historical data from the rollups forever. It just needs to ensure the data was available long enough for Layer 2s to process it and for anyone to verify it if needed. After that, it just takes up space. Pruning keeps the Layer 1 chain lean.
Makes sense. And the impact of proto-dank sharding, EIP 4844.
It was immediate and significant. It dramatically increased the amount of data an Ethereum block could hold. Think maybe a jump from around 90 kilobytes average to potentially up to 2 megabytes. A huge increase, like 20x or more.
And that translated directly to roll-up fees.
Yep, because posting data became so much cheaper for the rollups, they passed those savings on. We saw Layer 2 fees drop significantly, often by another 10x, almost overnight, after EIP 4844 went live.
Wow. So that already made a big difference. What's the next step then? Full dank sharding.
Full dank sharding is the ultimate goal. It basically takes the proto-dank sharding concept and scales it up massively. Instead of just a few blobs per block, the target is 64 blobs per block.
64. How much data is that?
That could allow for blocks potentially holding around 32 megabytes of data. Compared to the pre-blob era, that's like a 300x increase in data capacity.
That's enormous. How do they handle that much data without nodes getting overwhelmed?
Through some clever techniques. One is data availability sampling, or DAS. The idea is that validators don't need to download all 64 blobs in a block to be confident the data is available. They just need to randomly sample small pieces from different blobs. If enough validators successfully sample enough pieces, there's an extremely high mathematical probability that the entire data set is available.
So they check availability without downloading everything.
Exactly. It keeps the load on individual nodes manageable even as the total data capacity skyrockets. Full dank sharding also involves something called proposer-builder separation, or PBS.
Okay, what's that about?
It separates the job of proposing a block, selecting which block gets added to the chain, from the job of actually building the block, choosing which transactions go inside and in what order. This aims to make block production more efficient and, importantly, helps manage and distribute MEV.
MEV, maximal extractable value. That's the value block builders can get by reordering or inserting transactions, right?
Right. PBS aims to make that process more transparent and potentially more equitable, reducing negative side effects like front-running. So full dank sharding with DAS and PBS is the long-term vision. The goal is potentially enabling Ethereum, through its rollup ecosystem, to handle millions of transactions per second. But realistically, that's still several years away from full implementation.
Okay, that's a really comprehensive roadmap for Ethereum. Modular design, layer 2 rollups for execution, dank sharding for data availability. It's a massive undertaking.
It truly is a fundamental re-architecting of the network.
But Ethereum isn't the only game in town, right? As we mentioned, others are trying to solve scaling too. How do their approaches compare? Let's maybe start with Solana, known for speed.
Right, Solana. Its big selling point is definitely speed and low transaction fees. It consistently handles thousands of PPS, maybe around 2,600 in practice, with theoretical limits claimed much higher, like 65,000 TPS. Fees are usually fractions of a cent, maybe zeros and 2 cents.
How does it achieve that speed?
It uses a unique consensus mechanism addition called proof of history, POH, alongside proof of stake. POH creates a kind of verifiable timestamp for transactions before they're even bundled into blocks, which helps order them much faster. Solana has seen huge growth in on-chain activity because of this.
But there are trade-offs.
Yes. The main concerns often revolve around decentralization. Solana typically has fewer hardware-intensive validators compared to Ethereum, leading to worries about network control. And it's had, well, several notable network outages, which raises questions about reliability under stress. Its complexity can also be a hurdle. And interestingly, its adjusted staking reward for validators is often lower than Ethereum's.
Okay. What about Cardano? They always emphasized a research-driven approach.
Cardano, yes, pitched as a sort of third-generation crypto. They use their own proof-of-stake system called Ouroboros, developed through peer-reviewed research. The focus has always been on building methodically, aiming for high security, sustainability, and scalability right from the start.
So they claim to handle smart contracts, DeFi, etc., without the scaling problems Ethereum faced initially.
That's the claim: high security, decentralization, multi-asset capabilities. The challenge for Cardano has been adoption. Its very deliberate, research-first pace meant it was slower to roll out smart contract functionality compared to others. So while the tech might be sound, it hasn't yet attracted the same level of developer activity or total value locked or TVL as, say, Ethereum or even Solana. Its TVL is around $225 million, much lower.
Got it. And there's Polkadot focusing on interoperability.
Exactly. Polkadot's vision is different. It's built around a central relay chain that provides security, and then numerous independent blockchains called parachains connect to it. These parachains can be highly specialized, but can communicate seamlessly with each other through the relay chain.
How does that help scaling?
It allows parallel processing. Each parachain handles its own workload, so the overall network throughput increases. Polkadot achieves around 1,000 TPS system-wide. It's interesting conceptually. Polkadot's parachains are a bit like Ethereum's rollups, specialized execution environments.
But a key difference.
A key difference for you as a dev or investor is that rollups are essentially smart contracts on Ethereum, inheriting its security directly. Parachains are more like independent blockchains that lease security from Polkadot's relay chain, different architectural trade-offs.
Right. And Cosmos, also big on interoperability.
Very much so. Cosmos calls itself the Internet of Blockchains. It's less about a single central chain and more about an ecosystem of independent sovereign blockchains called zones that can communicate using a standard protocol called IBC, interblockchain communication.
So flexibility is key there.
Huge flexibility. Developers can build their own custom blockchains with their own rules, consensus often using Tendermint BFT in governance, but still connect and interact with other chains in the Cosmos ecosystem via IBC. It's designed for high scalability and customization from the ground up.
Okay, so we've got Solana pushing speed, Cardano with its methodical approach, Polkadot and Cosmos focused on connecting different chains. Are there others we should briefly mention?
Yeah, definitely worth noting. Avalanche, with its unique snow consensus mechanism and subnets allowing custom chains hitting maybe 400 TPS. Binance Smart Chain, or BSC, which gained popularity as a lower-cost, EVM-compatible alternative, though often faces centralization critiques. And Algorand, focusing on speed and decentralization through its pure proof-of-stake system.
It's a diverse landscape, and it seems like a running theme is that trade-off, right? Many competitors achieve speed or low fees by potentially compromising a bit on decentralization compared to Ethereum's path.
That's often the case, yes. Different chains make different choices about where they sit on that spectrum of the blockchain trilemma. Ethereum's modular roadmap is explicitly designed to scale while preserving its core commitment to decentralization. That's a key differentiator.
So looking ahead now, where does all this leave us? Ethereum's on this rapid transformation path, aiming for, 100,000 TPS.
Yeah, the eventual goal with full sharding and mature rollups is aiming for 100,000 TPS, maybe even more, with transactions costing fractions of a penny. That's the target within, say, the next 2 to 4 years, perhaps. Success here is absolutely critical for Ethereum to keep its dominant position in DeFi and dApps.
But you mentioned something interesting earlier about the Layer 2 tokens themselves. They haven't always performed as well as the tech might suggest.
That's a really important point for investors, yeah. It's been perplexing. The technology of L2s like Arbitrum or Optimism works. It provides real benefits, lower fees, faster speeds. But their native tokens have often struggled to gain significant, sustained value or market traction independent of ETH's price movements.
Why do you think that is?
Several factors, probably. Often, the token's main utility is just governance voting on protocol upgrades. That might not be a strong enough value driver for many investors. Plus, liquidity gets fragmented across all these different L2s, and there's just intense competition not only among L2s, but also from those alternative L1s we discussed.
So the tokenomics might not be fully figured out yet, even if the scaling tech is working.
It seems that way for many L2 tokens currently. Their
Right.
performance often feels closely tied to ETH's price and the overall market sentiment, rather than their specific L2's adoption metrics. It raises questions about whether they'll develop stronger independent value propositions over time. That's definitely a challenge for the L2 space.
Which leads to the bigger picture question, is the future dominated by one winner, or is it more likely a multi-chain world?
I think the consensus is increasingly leaning towards a multi-chain or maybe even multi-rollup future. It seems unlikely that one single blockchain will perfectly serve every possible use case.
So different chains specializing.
Exactly. You might see Ethereum solidify its place for high-value DeFi, complex smart contracts, maybe NFTs, acting as the core settlement layer. Then perhaps Solana or similar chains cater to high-frequency trading, gaming, or specific applications needing sheer speed, and other chains finding their own niches.
And if that's the future, then interoperability becomes even more critical, right?
Absolutely crucial. If assets and data are spread across multiple chains and rollups, the ability for them to communicate and interact seamlessly becomes paramount. Solutions like Polkadot's parachain system or Cosmos's IBC protocol or other bridging technologies will be incredibly valuable infrastructure in that kind of ecosystem.
Okay, so let's try to wrap this up. The big picture for Ethereum is this major shift to a modular architecture. It's leveraging layer 2 rollups, Optimistic and ZK, to handle execution off-chain, making things faster and cheaper.
Right, and simultaneously upgrading its own layer 1 to be a super efficient data availability layer through danksharding, starting with proto-danksharding's blobs and aiming for massive data capacity increases with full danksharding down the line, all while trying to maintain decentralization.
Meanwhile, the competition isn't standing still. Solana, Cardano, Polkadot, Cosmos, Avalanche, they all offer different approaches, different trade-offs, pushing innovation across the board.
It's a dynamic and competitive landscape, absolutely. Each has its own strengths and weaknesses, tackling the scaling challenge from different angles.
Which brings us to our final provocative thought for you, our listeners, the experienced investors and developers navigating this space. Consider this. If Ethereum does pull it off, if it achieves that vision of 100,000 plus TPS at near zero cost, becoming that truly scalable world computer while staying decentralized, what does that do to the necessity of some of these alternative layer ones?
Does it make some of them redundant? Or does it actually solidify that multi-chain future where Ethereum becomes the foundational settlement and data layer and other chains find highly specialized niches, creating an even more interconnected but diverse ecosystem?
What stands out to you as the most crucial development to watch, the one that will really shape this next wave of crypto innovation? Something to think about.